All right, here we go. We started now? Thank you. Section 7.4. It says parallel lines and proportional parts. Okay, so here's your parallel lines right here. So here's what you have to learn. This is just a theorem. We're not going to really prove this theorem or anything. I don't think they even prove it in the book. Nope. So we just believe it. All right, so it's a theorem. What happens here, you've got a triangle, and this one side is parallel to this other side right here, this third side. If you have that situation, let's do this in a different color. Watch, let's call this segment A. Now when I put a little a here, that means between this point and this point. Does everybody understand that? Okay, and we'll call this B, we'll call this C, and we'll call this D. You okay with that? Oh, excuse me. I'm having trouble talking today. I've been sick yet. I was in bed all day Saturday. And then I was in bed all day. I even missed church. I was in bed all day Sunday until just before to go to the games because I wanted to shoot the games. So
Are you like thrown up?
Yeah. No, it's just voice. Yeah, and just achy, just real achy and stuff. Oh, sorry. All right, so here we go. Watch this. There are some proportions here. This is only true if these two lines right here are parallel. Okay, you got to make sure you understand that. So if this line is parallel to this line, these proportions are true. So A, watch. You could write it several different ways. You could compare A to B. Now, if you can compare A to B, what do you think you're going to do with these two sides? C to D. Very good. All right, so that's one comparison you can make. You could make another comparison also. You could compare A to what?
C.
Right, so you could compare A to C, and if I compared A to C, what do you think? B to D. It just depends. It depends on what numbers you have and all that kind of stuff, what you're trying to solve for. It all depends. I'm just showing you the different ways you could do this. Now, I'm not going to write down a whole bunch of other ones, but you could write down some more. If I compared A to B, I could go the other way, couldn't I? I could compare B to A, then you would have to compare what? D to C. I could go C to A, and then I'd have to go D to B. You with me on that? So these are basically your two. Now, how do you know? Listen, watch this. This is important. How do you know that this is true and this is true? Well, you could always do what? Cross multiply and see. So if I cross multiply, what do I get? AD equals what? BC. What if I cross multiply here? You get the same thing, don't you? So as long as you cross multiply and you get the same thing, then your proportionals are the same, or your ratios are the same. They're in proportion. Okay? It's not really a proof. I'm just showing you that if I compared this one to this one and this one to this one, it's the same, right? A to C, B to D. It's the same as saying A to B, C to D. All right? Does that make any sense? Let me show you a way. I'll even do this in a different color. We'll do this in red. Okay? I want to show you a way that you cannot. I almost hate doing this because some people remember what I tell you not to remember. All right? But here's a way you cannot compare them. You cannot compare diagonally like this. Okay? So this is what you cannot do. Not. Okay? So you can't do this. You can't go A to D equals what? C to B or something like that. Looks like you should be able to, right? Go from this segment to this one, and then from this one across from it to that one. Because watch, if I cross multiply, look what I get. What do I get here? I get AB equals DC. Is that the same thing as we get down here? No, it's not. So, almost hate showing you that, but you can't do that, right? You cannot compare diagonally. As long as you compare across from each other, or top to bottom, if you want to call it that, okay, it's perfectly fine. So, how are we going to use this stuff? Well, we're going to use this stuff if I give you some lengths and you're trying to find one of the missing lengths, right? And then you can use these ratios to find the missing length. So let's do an example. All right, here's an example. I'll just put EX for example. That's S and R. It's a weird looking R, but that's supposed to be an R. All right, so it says PT is, let's write it down. PT is 7.5. And then TQ is 3. And SR is 2.5. SR is 2.5. All right, and then find PS. Find postscript. Did you know that? At the end of a letter when you write PS, did you know that's what it stands for? Pizza store. PlayStation. All right, here we go. Let's put the numbers in. What I would do, when they tell you stuff like this and you get a picture, I'm putting those numbers in where they're supposed to go. It just makes things a lot easier for me. So PT is 7.5, so that right there is 7.5. TQ, which is this one right here, is 3. SR is 2.5, so that's this one, 2.5. And we're trying to find PS, which is this one. Let's just call it X, just to make it a little easier for us. Now does it look a little more familiar?
Yeah.
Yeah, because now we can do that ratio. Now remember, you can only do this when this line is what to this line?
Parallel.
It's parallel to it, okay? So now we can compare it a couple different ways. It's up to you how you want to do it. You could go across. You could go X to 7.5. If I did it that way, then what would I have to do here?
2.5 over 3.
Right, 2.5 to 3. Or I could go X over 2.5 equals 7.5 over 3. You could do it either way. You could go backwards too. You could go you can go right to left. You could go bottom to top. It doesn't matter. So there's basically 4 different ways you could do this. Would you agree? I don't know. I like the X on top. Well, either one of these would be just as easy. Let's go X to 2.5. Is that all right? So if I go X to 2.5, what would I have to do over here? Yeah, 7.5 over 3.
Do you get like the same answer? It doesn't matter. Like,
Yeah, you get the same exact answer. Because remember when we cross multiplied, we had that AD equals BC. You're going to get the same exact thing. All right. So here we go. We can cross multiply, or if you wanted to, look, X is already on the top. In one step, you could do what?
Multiply by 3.
No, not by 3. You could just multiply by 2.5. You think it's hard doing that way?
Yeah.
All right.
Just,
Does it really?
yeah.
Okay. Well, for those who understand, I think it's easier to tell you the truth because you only have to do one step. But let's cross multiply. You guys love the cross multiplying, so we'll do that. So this is what? 7.5 times 2.5. And then we're going to do what to get rid of the 3? Divide by 3. Look, I get the same thing anyway, wouldn't I? Watch. If I multiply by 2.5, watch. Multiply by 2.5. I'll put it in parentheses. Look, I still get the same thing. Look, 7.5 times 2.5 over 3, right? Would you agree? But that was only one step. This was 2 steps. Anyway. Okay, I'm not trying to convince you anymore.
Oh, wow.
Look at that.
Is that new?
It doesn't really work.
Have I not? Oh, I haven't used this yet for you?
You always say everyone with the calculator. I don't have a calculator.
Well, on stuff like this,
nice.
this is when you use a calculator.
Wow.
So, right, you hit that and divide that by 3, and that equals 6.25.
I'm mad you really got a calculator on you.
6.25.
Not like, well, everybody has a calculator. You have like a serious calculator.
Well, I'm not the only one. Well, you know, I go through other people's, videos and all that stuff that teach math, and there's a lot of people that have calculators like that.
You have to download that one.
You do have to download it, yeah. All right, so there you go. That's your answer right there. So X is equal to 6.25. That's all there is to it. Pretty simple, isn't it? Okay. All right. Let's move on. All right. Here's a triangle. What we're going to do now is we're going to draw another side inside here like we did before. But what did I say about that other side inside the triangle before? It had to be parallel, okay? On this one, I'm not saying necessarily that it has to be parallel, but we're going to find that out in a minute. But what I'm going to do is I want to find the midpoint of 2 of these sides and connect the 2 midpoints together, okay? So I would say, well, no, it's not confusing. Look, find the midpoint of this side. So where would it be? About right there, wouldn't it? Okay. You think? Let's try that again. Because it'd be where these 2 intersect, right?
Okay.
Wouldn't it? So it'd be right there. Okay, so it'd be right there. Now I want to take, actually, here's the midpoint of that side. Let's find the midpoint of this side right here. I could have found the midpoint of this one if I wanted to. I just decided to pick this side. Let's find the midpoint of this side right here. So scooch that over. It would be about right there, wouldn't it? Alright, so I found the midpoint of 2 sides of the triangle. Now what I'm going to do is I'm going to connect the 2 midpoints together. Alright, so I'll tell you what, let's do that in a different color. connect this midpoint to this midpoint right there. So I never said that this thing was parallel to this, did I? All I did was connect the two midpoints to each other. But what do you think is true about that purple one and this side right here? They sure look parallel, don't they? Okay, and they actually are. I'll show you something in a second. Actually, on this one they don't tell you it's parallel, but it is. Okay, this will be parallel to this. But what they do is they tell you the name of this thing. They actually have a special name for this. I taught out of another book at my old school for years. They'd always talk about this segment right here as being the segment that connects the midpoints of two sides of a triangle. That's how they named it. All right. So it wasn't to this book until I actually heard somebody actually give it a more of a formal name. They call this the midsegment.
We talked about this one.
We have?
Yeah, segment. Yeah, what chapter was it?
Oh, okay. All right, good.
Yeah.
All right, so this is a midsegment of a triangle. All right. So the midsegment of a triangle, there's a couple. Yeah, we talked about it on trapezoid, right? Yeah. So let me see what's different about this. It's parallel. Okay, yeah. So they actually, there's two things that are true about this midsegment. The first of all was one that was a little more obvious, and we've already discussed that. What does that purple one look like to this bottom one right here? Looks like they're parallel. That's right. So, tell you what, let's put some letters in here. A, B, C. I'm using the letters from the book. This is R, and this is P. All right.
How do you jump from C to RP?
I went A, P, A, B, C, and then this is just R, P. All right. So, so what do you think is true then about them being parallel?
RP
I can do that.
parallel to C.
Good. R, P, right? Line segment RP is parallel to what? CB. So that's one thing we know. How many things did I say we know about this?
3.
Nope, 2. There's 2 things that we know about this. First of all, that the midsegment is parallel to that third side. Okay, and it's also, this is something we kind of talked about as the trapezoid, but it's actually half the length of CB. So RP, the length of RP is equal to half the length of CB. Right. So, for instance, what if that was 10? What would RP be equal to? It'd be 5. Simple. Would you agree? And they're parallel to each other.
You can just know this without any
If it's the midsegment, watch this.
and they'll tell you if it's the midpoint.
Well, they'll tell you this. They'll tell you that this is equal to this. So that's a midpoint, right?
That's a way of knowing it.
And then, right, that's one way of knowing. Now, they could tell you, you're right, they could say that RP is the midsegment. And they might not even tell you that that's the midpoint. But by knowing this is the midsegment, what does that tell you about that point? It has to be the midpoint. That's right. And if this is the midpoint, what's true about CR and AR? They have to be equal to each other, right? So they could tell you several things. They could say this is the midpoint and this is the midpoint, right? That means that's the midsegment, okay? Or they could tell you it's the midsegment. Or they could tell you that AR equals CR and not even tell you that that's the midpoint. But you should know that. Make sense? So they could tell you several different things here to figure that out. That's not too hard, is it? All right, let's do an example with that. You guys had asked me, how do you know if it's the midsegment or not? Sometimes they tell you. On this example, I'm looking at the top of 486 if you want to follow along. But it tells you that you have a midsegment. So let's put some letters in here. That's R, this is T, and this is S. And they say that this is a midsegment. So watch this. So if I go straight across there, that's a midpoint. And then if I go straight across here, that's a midpoint. Okay. So if I draw from here to here, that's pretty close. It says that that's a midsegment. That's X and Y. So at the beginning of the problem, it says XY is a midsegment. So if XY is a midsegment, tell me something about X. It's a what?
Midpoint.
It's a midpoint, right. Tell me something about RX and SX.
They're the same.
They're equal to each other. Tell me something about SY and TY. They're the same, and Y is a midpoint. Would you agree? if this is a midsegment. If this is a midsegment, tell me something about this line compared to this RT. It's parallel, okay, and it's half of the length of this too, isn't it? Okay, let's go on. It also says that, let's see, XY is a midsegment. Well, where is Y? Y is this right here. So that's not us. Oops. Where would the midpoint of this line be? It wouldn't be there because that's half of that. Where do you think the midpoint is here? We'll just eyeball it. Around in there somewhere? Okay. Well, it says XY is a midsegment. So that's XZ, I'm sorry. It's right there. Can't you see it? All right. So that's also, I didn't draw that very accurately.
We understand what you meant.
But it should be parallel to that. That doesn't look very parallel to that, does it? Is that all right? Okay, if you don't mind. If you don't mind, I don't mind. All right, so here we go. They tell you that this angle inside of here is 124 degrees. They say the length of this is 7. And the length of RT is 13. And that's all they tell you. And they ask you to solve for these three things. They say find xz equals, and then find st, and then find angle ryx. Angle ryx. Okay? Scooch that just a little bit. All right, let's see what we can do first. Xz. Let's try to find x. Wait a minute. Why would they ask for xz? Oh, I know why. Because I labeled these wrong. My bad. Oh no. You can erase.
RYX, how is that possible?
This one is z, and this one is y. Sorry about that. All right, now let's try it. Now let's try to find xz. This xz. Now it shouldn't be too hard because look, this is a midsegment of RT, isn't it? Okay, so if RT is 13, what is xz going to be? Right, it's going to be half of it, right? Let's do the math. 13 over 2 is, you can just write it that, or if you like 6.5 or 6.5, that's fine. So we'll write the answer right up here. When I say show your work, this is all I'm talking about doing right here. Okay, so you could say xz equals, that's showing your work. Showing me how you got 6.5. I just went 13 over 2. Does that make sense? Okay. Let's do st. St is this whole thing from here to here. I should be using different colors. All right, let's do st. Well, I know what xy is. All right, so xy is a midsegment, right? Because they tell you. They told you that xy was a midsegment. So tell me something about st.
It's 14.
Right, see, look, this is a midsegment. This is the other side.
So 7 times.
So this is half of this.
The whole thing's 14.
Right, so the whole thing's got to be 14. So the bigger one's got to be twice as big as the smaller one, right? Does that make sense?
Yeah.
All right, so st has got to be 14. So how do I do that? St, what's the work? How do I show my work? 7, how about times? 7 times 2. That's showing your work right there. Okay?
So when you write like ST, don't just write like 14, you gotta write like
Right, even if you can do it in your head. Even if you can do it in your head. Because some of you see quite frequently, unfortunately, that I say show your work a lot, don't I? Okay, Kenny, get your head up. Rayvon, get your head up. Zaria, sit up straight, please. Okay, here we go. What else? RYX. Let's find RYX. It's this angle right there. That's what we're looking for. You say, how do you know it's 124? Very good. You got it. Two lines are parallel. Watch. This line and this line is parallel. This is actually transversal, isn't it? Okay, do you remember this? Two parallel lines cut by a transversal. If this is 124, what's this angle right there? It's that one. And they're equal to each other, so that's 124. Pretty simple, isn't it? There's really no work to show on that one because there's no math involved. It's just looking. Okay? What do you think? Pretty easy stuff, isn't it? Okay. All right, let's do one more thing, and then I think we'll be ready to be finished. We'll do one more theorem, and then I'll do an example. We'll be done. All right, here's a little... Oops, I didn't want to make that blue. Or purple. I wanted to keep it... There we go. Sorry. Now I'm going to change it to purple. Okay, here we go. These three lines right here, they look parallel, but we don't know they are until they tell us, right? So now they are parallel to each other because I put the arrows there. Now, watch what happens, though. What I'm concerned about are the segments that are broken up. I got three parallel lines, and I have a couple transversals here. The angles of these transversals really don't make any difference at all. Let's call this little segment A. Let's call this one B. Do you see where A is? It's from here to here. And then B is from this point down to this point. Then I'll call this C and D. This is very familiar. Look, if I took this and I made it come to a point, I'd get a triangle, wouldn't I? And I got a parallel line in my triangle. Okay, so it's very, very similar to what we did on the very first theorem today. So you should have a pretty good understanding of what we're going to do before we even do it. So let's make some comparisons. This theorem says that the segments that are broken up are in proportion. So let's set up some proportions. A to what?
B.
B would equal C to D. C to D. All right, so A to B equals C to D. Good. What's another way you could write this? You could go A to C, and then you'd have to go what? B to D. Now, could you do this? Could you go A to C equals D to B? No, because if I go left to right, I have to go left to right. If I go top to bottom, this one has to go top to bottom. I can't go top to bottom, then bottom to top, right? Because if I cross multiplied, you'd see that you wouldn't get the same thing. Okay? What's another thing that I cannot do?
Diagonal.
I can't go diagonal. I can't go A to D equals C to B. All right? So make sure you don't do it like that. You either go across from each other in the same direction, or you go top to bottom in the same direction. Kenny, you getting all this? Stay awake. Somebody tapping, please. All right. That's that. Let's do an example, and we'll be done. I almost forgot. Let me show you one more thing. Watch. Let's bring this down to about right there. Okay. Now, well, I'll rewrite it then. Okay, so watch. What if I told you that this segment was equal to this segment? Now, just kind of, what do you think might be true about this one and this one?
They are also equal.
Yeah, they're not necessarily equal to this segment, okay? But these two would be equal to each other. Because if you think about this, what's my proportion? If I go A to B, what's my ratio? It's what? It's 1 to 1, isn't it? Okay, because anything over itself is 1 to 1. So what must this ratio be? It's got to be the same thing. It's got to be equal to 1 to 1. So this has to be 1 to 1 as well. Right? It doesn't mean that this segment is equal to this one. Right? But if these two are equal, then these two right here are equal. So if this was 3 and this was, let's say this whole thing, oh, oops, that was ugly. Let's say that the whole thing was 10. What could you say? Well, actually, nah, let's not. That's dumb. Let's say that was 5. Okay, so if this is what they told you. If this was 3, then obviously what's this going to be? 3, because these two segments are equal. But look at the scale factor. If I compare 3 to 3, that reduces to 1 to 1, doesn't it?
Yeah.
So this must reduce to 1 to 1. So if this is 5, this has to be what? It's got to be 5. Does that make sense? Okay, now we're ready to do an example. All right, let's take a look at this. It's given that this segment, I should have done that in yellow, right there. It's given that those two segments are equal to each other, and the problem says to, what, solve for x and y, I guess, right? So solve for x and y. So if these two are equal to each other, that's easy to solve for y. Yeah, absolutely. Watch. I'm going to do the bigger one first, right? Equals 3y plus 8. Subtract 3y, you get 2y. Add a 7, you get 15. Y is 15 over 2. You could leave it like that, or you could say 7.5 if you wanted to. That was easy because they told you those two are equal. Okay, you didn't have to know anything about things being proportional. But what did we just learn? If these two are equal to each other, what's true about these two?
They have to be.
Right, I never marked that they were equal, did I? But by knowing that theorem told me that these two have to be equal to each other. That's really all the geometry that we learned right there in that theorem. That was pretty easy, wasn't it? Just understanding that this was equal to this. Well, let's do the math real quick. Just remember how to
When
do
we get
this.
done, do we have to
Oops,
put?
x. You just have to solve for x.
But we don't have to put x in for.
No,
like,
they just say solve for x and y.
Okay.
Okay, if that's all they say solve for, you don't have to put it back into anything.
Okay.
All right. So let's do this. Subtract 4x from both sides, you get 2x. Add a 5, you get an 8. What's x?
4.
X is 4. Okay, there you go. That's it. Pretty simple, right?
Yeah.
Okay, absolutely, you got homework.
Is it just a worksheet?
Well, I was going to give you a worksheet, but I didn't have time to get it printed out this morning, so I'll give you something from the book. I'm sorry. I know you love the worksheets, but... So, oops, section, what is this, 7. I was going to put the page number. 7, 4. We're doing pages 489, 490. Let's go 10 to...
15. 12.
Let's go to 25.
25.
Okay? There it is, right there. Alright, 489, 490. Let's go 10 to 25.
You're killing me, Small.
Sorry, I didn't give you a worksheet, but we just ran out of time. So, you can do that. Okay, have fun with that.